We can use the maximum likelihood to infer the parameters of a categorical distribution from some observation of data. In the previous video, we showed that this is just the ratio of an observation to the total number of observations. But how does this work for a one-hot distribution where our dataset would look differently? Hi, welcome to a new video. Today we want to extend the maximum likelihood estimate for the one-hot categorical distribution. We saw in the intro that the one-hot categorical has a different form of a dataset, and this is because we use a different encoding for the state, as we use a one-hot vector. Recall for the categorical we used 0, 1, 2, 3 and so on, and we derived a maximum likelihood estimate. So make sure that you know how this maximum likelihood estimate comes to life. And now we want to do a similar thing for the dataset in the one-hot categorical distribution. This video will be mostly about how to implement it in TensorFlow Probability. And I personally think that the maximum likelihood estimate is also easier in the one-hot case, because we can here view the data set as a matrix. View the data set as a matrix. And we then get the following data matrix, which is most certainly upwards rectangular, and in the rows it has the number of samples, or in other words the capital N, and in the columns it will have the number of states as the capital D, and the entrance will for instance be like 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, and so on. And in order to find the maximum likelihood estimate, we have to define the NE, or find the NE, which is the number of times we observe the Eve state. And this is nothing else than the column sum that we have here. And we can do this by reducing our matrix into a vector over the first or the 0th dimension. So we reduce matrix to vector over first, or like let's call this the 0th axis. And then we get an n vector which consists of n0, n1, n2, and so on. And in the case of our weather, this would be here n0, the number of cloudy days, the number of rainy days, and the number of sunny days. And then we can define our theta array, or the maximum likelihood estimate again, as n0 over n, n1 over n, and n2 over n, and so on and so forth. Okay, let us implement this with TensorFlow Probability. I'm already in an interactive Python session with the packages installed. I will first create the true thetas array that we only need to create the data set, and then we can ignore it. And we think about the weather, and we have 3 weather states: cloudy, rainy, sunny, and we take probabilities, for instance 0.2, 0.3, and 0.5. Then we can create the one-hot weather categorical, for which we use TFP, the distributions dot one-hot categorical, and the probabilities is our true thetas array. Then we can create the data set, which is the weather one-hot, sampled, for instance, 100 times. This will be our capital N. And if we look at a data set, then we see it already is in the format of a matrix where each of the rows only has one entry, which is 1, and the others is 0. Then we can create the n vector that I talked about. For this we will use tf.reduce sum, and we will reduce our data set. And then really important, we use the 0th axis, so the axis alongside the samples. And then we can look at the n vector, and we see we have 23, 25, 6, and 51. And then we can divide this vector by 100. And then we get our maximum likelihood estimate, which is 0.23, 0.26, and 0.51. And if we look at the 3 true theta values we see, they are off. But as usual, this is because of the way the maximum likelihood estimate works. Thanks for watching this short video on the extension of the maximum likelihood estimate for the One-Hot Categorical. Here you can find more videos on similar topics. Thanks for watching. See you next time.